Hello, everybody, and welcome back to Wow 11. I'm Paige Hattie, the director of Mobius Connect, and I'm super excited to be here with today's presenter for the presentation today. So we have unearthed the full functionality of the All-Test Pro 7 electric motor PdM instrument presented by Simon Young. So I know he's got a great presentation in store for you guys all today. So that being said, if anybody has any questions while Simon's presenting, go ahead and drop them in the question panel on your webinar screen. And if we have some time at the end of today's session, Simon will be more than happy to answer some questions for you. All right, so that being said, I'm going to bring on Simon. Are you there with us?
Yeah, good morning, good afternoon. Hey people, it's lovely to have this opportunity to talk to you all today. We're really excited that you could give us your time, and we do appreciate that. I've got my colleague Andy with me, Andy Tomaccio, and hopefully today we can share some interesting information that's going to help you in your condition monitoring programs, troubleshooting, and just in general, making hopefully your lives easier. So in this short webinar, we're going to show you the tool and hopefully really answer some good questions as to how you can use this instrument. So basically, All-Test Pro has been in the motor testing troubleshooting, improve your reliability world for well over 30 years. And we've been pioneering our test instruments that are truly handheld, battery operated, portable devices. And the main thing out there, why we're in the business is because unfortunately motors fail. And we want to provide you with a tool that is going to help you find developing faults within the motors and really help your facility with its uptime. So that's really really important to us. So it doesn't really matter what type of facility you have, but at the end of the day, downtime is money that's being burnt, and different industries have different costs associated to them. But the lost time is absolutely, a real drain on the blood of the body that you work for. So we want to try and improve that, cut that out where we can. And so motor circuit analysis, the de-energized testing that we're focusing on today with the AT7 can really help you. So why test motors? Well, as we've said, they will fail. And they can fail at the most inconvenient times, as you know. So clearly, troubleshooting is a very key area that we like to address. It's a common entry point, but there are other areas that are really critical to your business that you may not have potentially looked at. And one of those areas is incoming inspection. When you receive motors that are new or perhaps repaired, testing those motors first it can be really, really valuable. Then obviously we have our PdM condition monitoring program. Many facilities are looking for the benefits that type of program gives. And then, we have the whole area of actually improving the commissioning process when you're putting in or taking out motors into your system. We're also looking at some really important cost savings that you can have with regards to energy usage. You've also got the important area of health and safety for your people at the plant. And those areas are all really critical and all have a huge payback to your business. So obviously, equipment failure is well recognized. There have been many studies out there that have looked at it. And unfortunately, it doesn't just depend upon age as being a critical factor in failure. It's quite often the case that you can have something new that's put in that can be very problematic. So dealing with your plant, your world, your facility, it's critical to make sure that everything is surveyed, and so that you have the ability to really focus in on those small, 1 to 2, maybe 3% areas where you've got some concerns. Okay, so types of motor faults that we see. Obviously, there are common areas that people are familiar with, things like bearings, broken rotor bars, elements like that with the shaft, alignment and so on. Those are sort of very well established, and there are tools out there like vibration that are used for diagnosing those issues. But we've also got tools like electrical signature analysis that is undertaken with our energized tester, the APPOL 3, that can be very good at helping you establish and working alongside with a vibration program. Now, when you get to the electrical side of it, the standard that many facilities have been operating with has been the good old insulation test, because really at many facilities, the primary focus there is that motor safe? So the insulation test, the ground wall is a basic safety check, but that doesn't help you in finding those core-to-coil, turn-to-turn type faults. And that's where motor testing using motor circuit analysis that the 87 is using is really going to help you. So we can see with MCA, as I said earlier, core-to-coil, turn-to-turn type faults and phase-to-phase. And we can also do the insulation test, so we can see ground faults as well. So this chart here gives us a good flavor of what is done at many facilities. And as you can see, the green gives you an indication of an early developing type fault. A yellow indicates that it's a late stage fault. And you can see that there's a lot of areas that you are really missing out on early stage information. Now, if we go to the method where we would be using both de-energized, that's MCA, motor circuit analysis, and electrical signature analysis, all of a sudden we have a larger area of early fault finding. Now, if we focus in on the MCA line, here you can see that we can look at connections, cables, we can look at the stator, the rotor, air gap, and so on, and see these early stage developing faults. Now, that's something that you're not going to be seeing with your insulation tester, and it's certainly something that if you're using polarizing DEX, PI, and so on, that it's not going to do anything for you with regards to those developing core-to-coil and turn-to-turn faults. Really, they are very much looking at the ground wall insulation. So MCA, right out the gate, gives you this developing information. Okay, you may be wondering what the bloody hell was that? And that was just a little wake up, because it can get really boring having to listen to someone droning on. So hopefully you weren't too offended by that, but you know, you've had a long week, and I just wanted to make sure that you were feeling refreshed and awake. So after that, we're really drilling down into what we're doing with the MCA product. And our main testing instrument is the instrument called the AT7 Pro. And the AT7 Professional is, as we said earlier, a handheld battery operated device. So this is truly a field testing device. It's light. Okay, I can use it out in the field, and I don't have to plug it in. I don't have to have a cart. I don't need to have any software actually with me. I don't need a computer. It's a fully functioning device on its own. And we're using motor circuit analysis, MCA testing, which covers resistance, impedance, inductance, phase angle, current frequency, our secret source, which is test value static, known as TVS, and also our dynamic stator and rotor. And what we're able to see, as we mentioned earlier, are those developing core-to-coil turn-to-turn faults. We can see connection issues and so on. And we'll explain how and show you how the tool works a little bit later on. So as you can see, back to the gap chart, again, you can really see how with MCA added into your current toolkit, it really does give you an excellent early stage fault finding tool. Okay, so I'm going to pause here for a second. We have a great software program we'd like to show you, and we'd like to show you how the instruments are actually working. So I'm going to stop with the PowerPoint for a second, and we'll shift over to the camera. Okay, and hopefully you should be able to see the camera, hopefully. Okay.
Yep, your camera's on, Simon.
Great stuff. Okay, well, just an introduction. This is Andy, and I'm Simon. Okay, Andy obviously is clearly the more beautiful one here, and speaks with a much better accent than I do. Okay, so looking at the instruments here, this is the AT7. Okay, and as we mentioned earlier on, it's battery operated. It uses a lithium-ion battery pack in there, so you get a good day's work out of the tool. And you can, when you turn the instrument on, the first thing that you're going to see is the warning not to connect this instrument to live power. And you're also going to see that it tells you that this is the professional version of the AT7. And what that means with the AT7 Professional, it's going to give you the ability to test AC motors, DC motors, transformers. It's also going to give you a route function, and it's also going to give you access to a works order function in the software. And this, as I mentioned, is our main full instrument. Okay, so when you click OK, the screen then presents to you the main menu options, and you'll see that the icon on the top left there is highlighted. So the navigation for the tool is basically via the keyboard, and you can move the up and down, left and right arrows to actually navigate through the screen. So if I hit the down button here, you can see I've actually moved down to the Z-Fi test. Okay, so when I'm looking at the icon that was highlighted, what does that mean? And there's a picture there of a motor, and underneath it, it says IND. Well, the IND test is optimized for testing the most sort of common motors that are out there, which are the AC squirrel cage induction motors that are less than 1,000 volts. If I'm going to be testing something over 1,000 volts, then I would move to a different test option, which we'll get to in a minute. But basically, we have here a little fault motor that we're going to be using for today's demonstration. And basically, this is obviously a squirrel cage motor. Now, we have played around with this motor to give it some basic faults. So that gives us the ability in a conference or this type of environment to actually show you what's going on. But the principle is exactly the same out in the field. So we're on the IND test. We're going to click OK. And now you'll see that the screen is giving us an on message prompt, and it's asking us to connect the blue clip, which is the phase 2 lead, and the yellow, which is the ground lead, as far as we're concerned. Now, this was a great improvement over some of our older instruments where they only used to have 2 phase leads, and you would have to move those phase leads from one set of connections to another and keep repeating that until you completed the test. Now, I'm pleased to say, obviously, with the type of Kelvin bridge resistance measurement that we've got in there, we are able, once we've made our full connections, to leave those alone during the actual motor test. We don't have to move them around, which is wonderful. It saves time, cuts down on connection errors, and so on. So we're now at the point where we're ready to hit OK, and straight out the gate, again, you'll see that the instrument is guiding you. It's advising you that, look, we're on no. We're presuming you don't want to do this particular test. Now, the test that we're doing at this precise moment is our dissipation factor and capacitance test, which we use for establishing contamination. And we perform this particular test directly at the motor. Okay, so we're going to say yes, because we are directly at the motor. Oh, okay, we'll just redo that again. Okay. And now we're carrying out the capacitance and dissipation factor measurement. You'll see there's a yellow light on. That means we're injecting a signal into the motor. We've got our results there on the screen. And for an experienced user, we have the DF number there, which is 3.28%, and the capacitance number, which is 37.05 nanofarads. But for the more basic user, you don't have to worry about what those numbers are actually telling you at this precise moment, because at the end of the test, on the screen of the instrument, it's actually going to give you the summary, the test results, and it will give you that in a very easy to understand and logical way. So we've got some measurements, and we're now going to click OK. So again, we're now being asked by the instrument, do we want to do the insulation test? And obviously we do. So we're going to say yes. So we're going to click OK.
It might be worth noting, this is the insulation to ground test. This is our safety test. This is not the wind. There's 2 forms of insulation in a motor. There's the insulation to the ground, and there's the insulation within the windings. This is your safety test as we're going through here.
Thanks, Andy.
So we have the capability of testing at 500 volt or 1,000, up to 5 gigs. Since this is a safety test, we could terminate at 5 gigs because under any safety protocol or national standard, at 5 gigs will meet every standard. So we know this is a safe motor to run now. Simon?
Okay, so now we're going to click OK to lock that in. Now, before we hit OK, we had the ability to retake that test if we wanted to, but to actually lock it in, we had to hit OK. Now we're on to the next stage of the motor test, and as you can see here, the instrument's actually asking us to connect the remaining clips, and that's going to be our black, which is our phase 1, and our red, which is phase 3. And they, as I mentioned earlier, these are true Kelvin clamps. It's got a true Kelvin resistance bridge inside the instrument. So we're looking at very accurate measuring. Okay.
So it's very user-friendly. As we continue on with the test, we see that we have a no connection. Intuitively, we correct our connections, and the test will continue on.
Yep, that's a great point, Andy. So just to go over that, if you have not made a good connection, the instrument is basically telling you that you needed to complete the connection. Okay, so the light down over here, the yellow light or amber light, is basically indicating that we're injecting our sinusoidal signal into the motor system, and this is not destructive in any shape or form. This is low voltage. So the great thing here that you're able to do is get information on the condition of your windings without having to over exercise them, which is something that you know, out in the field, surge testing really is something that you know, we don't want to be doing.
So I think we forgot to mention, but we're mimicking a brand new out of the box initial test right now. We're essentially getting our baseline for our system, understanding what the motor is good out of the box before we install or we store or we move on, or we actually, if we find issues, we return back to within the warranty period. Simon, we're on to dynamic.
Yes, yeah. So now at this stage, the instrument is asking us if we want to continue on and do the dynamic test. This is, as we just mentioned, a brand new motor that we're testing the scenario. So what we're going to do here is we're actually going to say yes. So we're going to click over here, click OK, and you'll now see that the instrument is ready to perform the first part of the dynamic test. And he's got the rotor at the 12 o'clock position. And so now we're going to click OK. And we're going to rotate at a steady rotation speed. And you'll hear, if I shut up talking, that there's an audible timing tone to assist you on taking the dynamic part of the test. Now, what we're actually doing here is we are looking at the stator and the rotor in more detail, and this is going to give us a complete test that we can use as a baseline, as a reference test going forward. So now we're ready to do phase 2 to 1. So I'm going to click OK. Andy's at the 12 o'clock position.
And this test is based on poles or RPM of the motor, and we have rotational guidance based on that. So if this motor we're conducting a test on is a 3600 two-pole motor, so this is actually our fastest cadence we will spin the motor at for rotor and stator signatures. As we go to 4-pole, 6-pole, and 8-pole, we would actually spin slower because there's more poles to get test data on.
Okay, now we're ready to carry out the final phase of the testing. So that's phase 1 to 3 that we're going to do. Again, click OK, start the rotation. So the testing time, you can play this back. It's under 3 minutes to do the complete test. Now, the really excellent thing about this baseline that we have here with our reference test is future tests can be carried out by comparing a static test to the saved reference test. And we'll explain that in a minute. So here we go. So as I mentioned earlier, the screen is displaying the summary results for the motor test. And the key thing here, if we're looking at this scenario as being a brand new motor that we wanted to do acceptance testing for, as you can see, this is pretty straightforward for say a store person to actually be able to do this for you. And we've got a good result on this. So the first thing that we're going to do is actually save this test. We want to lock this piece of information in.
Save it as M1, Simon, please.
Yeah,
M1.
I will. So I'm going to save this as a reference. You can see that I've got various different options on the save. So I click OK here, and I'm going to type in the M, and then I'm going to change my characters. You'll see the ABC at the top is going to change to numerical, and then I'm going to put the 1 in, and then I'm going to move my up key, my up arrow, to next. You'll hear that beep. You'll see that next is highlighted, and now I'm going to click OK, and that saved that test into the instrument's memory. Now the great thing there is the instrument will store over 500 tests in its memory, and obviously you can upload this data into the software program, and then you can begin to trend and evaluate information as you take it. Now, out in the field, you may want to look at this in more detail. So you can see by clicking OK on the resistance measurements, you can actually see across the different phases the actual resistance measurement. And what we're looking for are balanced, for a balanced motor, are like-for-like numbers. So basically within the instrument, you don't have to set any of the alarms. They've been preset in there, but we have a variance for coming up with a warning, so 3 to 5%, and then over 5% we would be coming up as a bad, which would be indicating that we have a significant variance on the measurements. Okay, so if we come down to our stator, here you can see that we have got our basic dynamic signature here, and this will be displayed also on the software test report and test data for that particular motor. We have one for our rotor, and then we have our contamination measurements, and then we have our insulation. Okay.
The best part about a three-phase motor is there's 3 separate windings that should be exactly the same. So testing against each winding is the perfect opportunity to make sure you have symmetry and balance. And if you go outside that balance, our calculations will let you know immediately. And that's where we find the developing issues.
Okay, so now we're going to exit out of this particular test, and we're going to change the scenario for a minute here. We're going to be coming back to this motor 6 months later. It was installed when we took that test, and so we're just going to do a follow-up test. So we click into the industrial test again, click OK. This time I'm actually away up at the MCC. So the idea here would be that I want to test with the greatest run of cabling possible, furthest away to catch any faults and so on the motor system. So because of that, I'm up at the MCC. I don't want to do my capacitance test. So I'm going to click OK.
And that's just because of the sheer size of the system could be it would drain the battery. So that is strictly a motor at the motor test.
And then I'm going to do the say no to the insulation test, because I might have some sensitive electronic equipment actually on the line. But if I haven't, then I could do the insulation test. But at this point, I'm saying no. And I'm going to go straight in, and I'm going to do the winding test. So you'll see that the instructions there that I'm being given by the instrument are great guidance for your colleagues who would be using the instrument. So again, while the instrument is doing the test, we're starting on phase 3 to 2, then we move to 2 to 1. You'll see the black bar is working away across the screen. And we're basically testing over a frequency range from 60 hertz up to 800 hertz, get the best frequency response, and then we are performing our MCA testing. Okay, we're almost finished on our final set of phases. And so when this has completed, the instrument's going to ask us, do we want to do the dynamic test, or have we finished? Now, the great thing here, as I mentioned earlier on, we've got that original reference test that we took, and so we don't now need to undertake the dynamic test. We are going to use this static test and compare it to the saved reference test. So I'm going to click OK to say no. I've now got the test information here showing. So you'll see that I've got an OK for my resistance measurements. And if I come down to my stator and my rotor, you'll see that we've got user reference, and then NOR for contamination and insulation. Those mean that I haven't taken those particular sections of the test. So hence, there's no result. So the first thing I'm going to do, come down and I'm going to save that test, because the data, I want to upload it into the software at a later date. I might want to share it with my colleagues. So it's important that I capture this information. Remember, many of your colleagues that are using a megometer won't be used to saving this type of data. So when, as a team, you're using this type of tool, you really want to educate them on the importance of saving test data.
Simon, please name this one MS1.
Okay, so I'm going to click OK on my save. Now notice this time I didn't go into the reference save, I just went into the save, the basic save. MS1, you say? Yeah. S, and then I'm going to OK, and then 1. Okay, so the same process again. I changed from alpha to numeric, and now I'm hitting the up key to the next, click OK, and I've now saved that into the memory. So that was important. Now I've locked that into the memory, and I've got my test results here. I can pop down to my stator measurement, and you'll see here it's saying user reference. What the hell does that mean? So here the instrument has calculated out using our patented TVS measurement, and we have a TVS value of 683.05. Well, what the hell does that mean? Well, if we now come down to save reference, click OK, and instead of going to save, we go compare to a reference, we can now browse the reference memory, and we can find the test that we saved,
which was M1.
And here we go. You'll see here M1. I'm going to move across to use this test to compare, and here we can see that there's been basically no change in the condition. We've got OK. So right out the gate, out in the field, I've got this ability to compare my new test data very, very quickly to the original data that I took. And this is optimized for our squirrel cage AC induction motors at less than 1,000 volts. But we do calculate the TVS value on our other larger AC motor tests as well. So now the next scenario is we're coming back to this motor, and I'm going to test this outside of the industrial test. I'm going to test this using our main Z-Phi test, which we would normally use for testing motors that are over 1,000 volts. So I can click OK here. And as you can see, the options here are I can test motors, I can do transformers, And with this particular type of test, because I am not using the TVS and the dynamic signature, potentially I've got the option to do what we call a rotor compensated test. And that's an important point to note, that with the industrial test, we no longer have to worry about the influence of the rotor on the winding, because we allow for that with our patented test. So you can take that test as we did from the MCC, and you're not having to worry about the position of the rotor. Now, with the Z-Fi test, here potentially there will be occasions where I will have to do that rotor compensated test to confirm that the rotor isn't causing any form of imbalance on the measurements. So click OK. And the great thing again, you'll notice that the information, the prompts here, the way that we're actually carrying out the test, the instructions are basically the same. So I'm going to take my basic insulation test. So I click OK. Sorry, I beg your pardon, my capacitance test. I'm going to say yes to that. Okay. Okay, I've got my measurements. I'm going to click OK. Going to do my insulation test. Okay, click OK. And now I'm going to take my winding test. So from a user's perspective, learning how to use this tool, it's very, very easy. Because we have the same basic structure to each test that we're performing, user adoption is very fast. It makes it a lot easier for people to learn the technology.
It might be a good point to note right now that you notice that resistance is always separate on top. We've found that electrical resistance principles are so robust that it's usually, if you're going to have issues leading to resistance, that's going to be the last thing to present as a problem before the other electrical principles we do our TVS on.
Okay, thank you, Andy. Really appreciate that. Now, you'll see now on the screen, we have, again, our test summary. And as I said, this time we've tested this using the Z-Fi test. And if I follow the protocol, I want to go down and I want to save this test information. So I'm going to click Save. And what one do you want to call it?
Let's go MZ1.
Oh, very nice. I like it. And then I click OK, and I'm going to change that to 1, go up to there, click OK. All right, so I've now saved that test into the memory. Now, you'll see here that I have a range of measurements that are showing up, but you'll notice that the stator and the rotor, it's saying use a reference, okay? So if I was dealing with a potential fault in the winding, then I would expect to see on this particular test the current frequency and phase angle showing as either a warning or bad. But because this is a squirrel cage induction motor and I've got a previous reference test, I can actually compare to that reference test. So that gives me the ability to go down to save as a reference, go to compare to a reference, click OK, browse the memory, and I'm going to browse through, and I'm looking for my M1 motor, click OK, and you'll see there that, again, there's been no change in condition of that motor. So I can move on to the next motor that I'm looking to test. Okay, so very quickly, now I'm going to put this into a fault mode for a rotor fault.
Yep, rotor stator, yep.
Yep,
Shorted
a shorted white. Thank you. The brain was not working there. So I'm going to now hit remeasure, and I'm again get the same basic instructions. I'm going to say no to the capacitance. I'm going to say yes to the insulation test, just to give you the fact that you can test a motor and have good ground wall insulation, but you can have very deep down there a winding fault that is developing. So now I'm carrying out the remainder of the winding test. We've got about a minute left, I think, roughly. So bear with us. We'll have the result up very, very shortly. So using the test data in the software program is very easy. We have a basic USB cable that's used to upload the test data. You can create a company. You can create multiple companies if you want. And then under the company, you can create locations where you would then put your motor asset in under that particular location. And you can build up your database. It's going to advise you of the condition of the motors when they're overdue a test and so on. And you can print test reports for management, trend reports, and so on. So again, protocol, I'm going to save this test. So I click down here, going to save.
M4Z or MZ4.
Yep, and Z. Whoops. Sorry, that's my fault. Rushing. Oh, that's my fault. I didn't mean to do that. MZ4, you said?
Yep.
Okay, sorry about that, guys. Okay, come up to next. Click OK. That's now saved. All right. So this time you can see on the screen we put this motor into a shorted winding, and we can see that the stator, now the TVS value has changed significantly, and we've also got an indication of an issue here on our phase angle, because we can now see that we have a significant change, and also on the current frequency. So if we now come back down to the save reference and go and compare this test to our initial reference test, so the M1 test, come across, use this, and you can now see that the TVS has oh gosh, what's the word? It's changed from good to bad, because the deviation has exceeded our alarm limit. So it's over 5% deviation.
Compared to our good baseline.
Yeah, thank you, Andy. Compared to the good baseline. So with the software program, we can upload this test information into the software program. Each test is time and date stamped. The software program has the ability to add photographs into a particular test. So there are lots of usage for your motor program, where you can maybe argue for purchasing a higher quality type of motor, or maybe you want to share data with another facility. So that really gives you a lot of strength. So the areas that we were trying to cover today were basically incoming inspection, your backup spares, all of those motors in there. You can very quickly survey and get a good handle on the condition of those motors. Then you would be using the instrument at the point that you're changing out a motor, at the point that you're condemning the motor. Is that motor really the problem? So you would test, you would verify that that is the problem, and then you would test the new motor you're installing at the point that you're swapping out. And then further down the road, you have the condition monitoring, PdM type of program where you can build up and you know, build up a good control of where your system actually is. And then finally, goes without saying, basic troubleshooting. Maybe you have VFDs on some of your motors. The VFD goes into a fault mode. Do you call out the drive specialist? Well, if you have one of these motor testers, you have the ability to really verify, has the sensitive drive picked up that there's actually something going wrong with the motor, and you can verify that you have a developing winding fault using the tester. So the AT7 really helps you build a better understanding of your motor systems. One final point, the instrument can be used with the AT34. The AT34 has the same industrial test function. And then we have our energized tester, which is the ATPOL 3, which in conjunction, as we mentioned in the PowerPoint earlier, gives you that widest range of testing from incoming power, the motor, the driven load. You can really save yourself many hours of pain. Okay, I think I've reached my time limit, I think. So thank you very much. And I don't know if there are any questions, Kim, Paige, if we can help.
Yeah, absolutely. Thank you guys for that great presentation. That was awesome to see everything in motion. So like Simon said, guys, we're going to open up for questions at this time. If you haven't already submitted a question and you would like to, go ahead and drop them in the questions panel on your webinar screen. And we will take a couple of minutes here to get those questions answered. So let me see here. We did have a number of questions that came through while you were doing that, Simon. So this person is asking, what happens if rotation is not steady?
Great question. Great question. And
typically, that's the number one phone call we get after a unit is purchased is inconsistent testing. So anytime you have a bad test, we tell you, and no matter what that test is, to verify that by doing it again. Then second is, yes, we want a slow, steady cadence. And we offer guidance per pole. That cadence is determined by the poles or RPM of the motor, and we offer guidance. And typically, it's per angle per beat.
And the key thing here is that we don't want you rotating the shaft of the motor with your fingers. What we want you to use, we actually have a shaft strap that we provide with each instrument that actually helps you maintain a smooth and steady rotation. It's actually very challenging to do it by hand. Great question. Thank you very much.
Every time you touch the shaft, you essentially stop it. So.
All right, fantastic. I love that we're able to look at these things live with you guys. It's so much fun. So moving on here to our next question. So this person is wondering, what is the time period for the next test on the same motor?
Oh, beautiful. Love this question. That's great. So in our manual, we give some guidelines on how often you may want to test. The key thing is that you perform regular testing, and if you've done your survey. So in my book, you get the instrument, you do your backup store, you instigate the program of acceptance testing. Very importantly, you instigate the commissioning process so that you're using the tester in that. Then really, 6 monthly, yearly is viable, and you're really going to be focusing on that smaller, under 3% of problem areas that you really want to test more regularly to evaluate, where you are with regarding an actual decision to change that motor out.
just going back to the previous question, this is the strap wrench type thing we recommend for dynamic testing.
Yes, and that's provided with the instrument as well. Thank you, Andy.
All right, great. Thank you, guys. Okay, so moving on here to our next question, and these are all awesome questions, guys, so keep them coming. We do have a few more minutes left here. So this next one up, guys, is asking, what is TVS?
Okay, so TVS stands for test value static, and it's our patented test measurement. If the person wants to would like some more information on that, I'd be happy to actually send them one of our bulletins. Be more than happy to give some more detailed information. But basically, what we're able to do with TVS is no longer on those AC squirrel cage induction motors, no longer do we have to worry about the position of the rotor. That's taking the need out of the motor testing equation to have to do a rotor compensated test if you have an unbalance on the reading.
It's a test value static does not include in resistance, as I was trying to state before. Resistance is such a robust electrical principle that's usually 95 to 99% of the time is an issue of connection. Like your novice electrician will have trim the connection and use the wrong size wire nut or something like that, or you just have a bad solder joint. So TVS and TVS is basically one full day of our training facility, training program. So I definitely would recommend hopping on ATP's website and sending us an email, and we'll send you the bulletin because we could do a lecture on TVS.
Perfect. Thank you, guys. And I think that leads perfectly into one of our other questions here. This person is wondering about training opportunities.
Oh, thank you so much. And I apologize. I was amiss on not mentioning this. So we're really pleased to have Bill Kruger, who is our lead training director. He's been with us for many years. Bill
is the Morbius vet too.
Yeah. Bill is highly educated and has been a stalwart in vibration for many years, and then moved across to MCA and ESA. The training program that we offer is split into a number of different options, because since the advent of COVID, it's not been feasible for everybody to obviously be able to travel. So we've developed some virtual programs where we run through the training, and we are also doing on-site training. We can do virtual customer training for large facilities, or as I say, we can come onto site. I'm very pleased to say that we offer a level 1, which is the introductory course, and then we do offer a level 2, which is the advanced course. We've also been developing more e-learning functionality as well. So watch this space. We take training and the impact that has on our customers very, very seriously, and I'm really proud that we've got a good team there that really helps people maximize the potential of the instruments.
And specialized BPO too, so you might want to mention that.
Yeah.
And we also offer specialized hourly training opportunities too. We call it button pushing orientation, but it's really a broad spectrum specific to your questions. Like you get trained up and stuff like that, and you still would like some specialized 2 or 3 hours to continue the discussion or work more deeply into the software, or maybe you are using different motors like wound rotor or synchronous or a DC or transformer.
Yep.
So and you just need a couple extra hours. We have those opportunities for training too.
Thanks, Andy.
All right, guys, beautiful. And to follow up as well, Bill Kruger is awesome. We've had him host many a webinar with us. He's fantastic. So that's we can affirm that. So we're going to close things out here for today, guys, with one final question, because unfortunately we are a little bit shy on time and we're running to a next session here shortly. But for our final question today, and if anybody in our audience has any more questions, please enter them. We will make sure that Simon and Andy get a copy of them and they'll follow up with you privately. But for our last question for today, this person is wondering if the Pro 7 or any other testing devices can be used to test the motor and electric circuit, breaker to motor, with the motor running or in service.
Oh, that's a great question. So the MCA instruments, so that's the AT34, the AT7, and the AT7 Professional. Those are all de-energized testing instruments. The energized tester is known as the AT-Pol3, and that uses electrical signature analysis. That instrument will carry out a full power quality, incoming power assessment, and we'll also look at the running motor and the driven load.
While under power.
While under power. But it's important to note the best technology that we have been able to develop to date for finding those developing coil-to-coil, turn-to-turn, phase-to-phase winding issues is de-energized. And that's why we push the AT-Pol3 energized tester in with the AT7 Professional in our complete assembly, which is known as the MD3. And that gives you the greatest coverage for finding those early stage faults. It's a great compatible tool with other reliability tools that you'll have in your toolkit. Works great as an excellent counterbalance, for example, with the vibration program and so on. So anybody that's interested to learn more about that, please let us know. We've got lots of white papers and tech tips that we'd be pleased to share with you.
Perfect. All right, guys. Well, is there anything else that you would like to add before we close things up for today?
I'd just like to say thank you very much, Andy. You did a great job, and Paige and
appreciate it.
Sorry, I've forgotten your name. It's gone out of the head. But anyway, ladies, thank you so much for your help today. And people out there, keep safe. Really appreciate your time, and look forward to seeing you again. Thank you very much.
Awesome. Thank you both. It was a pleasure having you. That being said, everybody, before you jump on off, let me just go through a few final reminders for today's session. So if you haven't already attended a WOW 11 session, just a quick informational bit here. If you're in the Monterey or Perth area, we would love to see you live and in person at our upcoming conferences. You can use discount code WOW50 to save 50% off on your live conference attendance. So we would love to see you there if you're in the area. You can visit our live conference website, mobiusconnectconference.com, to learn more about those. We'll also include more details in a follow-up email from this webinar today. And coming up next, guys, we've got a very, very special treat in store for you. So we've got Robo Olympics, a futuristic gaming session. So if you haven't already signed up and you would like to sign up for Robo Olympics, you can head on over to the Attendee Hub. You'll get access to the Zoom link to jump on in and join us. It's going to be a different kind of session, and we're in for a really fun time. It'll break up the day really nicely. So if you get a lunch break, or if it's your evening time and you're able to join us, we would love to see you over there. We're going to have a blast, and there will be prizes and a lot of fun and a little bit of networking, but some healthy competition to almost round out WOW 11. So that's coming up next here in about 15 minutes. And then we also are super, super excited to share the grand reveal for the next WOW. So WOW 12, can you believe it? Honestly, we've done 11 of these now. So WOW 12 is coming to you the last week of January 2024. So if you're interested in attending and speaking, be on the lookout for more details. Those will be coming to you soon after we wrap WOW 11 up today. So stay tuned for more there. And then as always, guys, you are welcome to join us in the Mobius Connect community over at mobiusconnect.com. We've got the live feed, forum discussions. You can always network with other members. There's over 10,000 of you that actively participate and have profiles within the community. So we'd love to see you over there if you're not there already. And of course, you guys can follow us and stay up to date with all of the latest community happenings at Mobius Connect on all major social media networks. And if you guys have any questions, suggestions, feedback, or if you'd like an introduction to Simon and Andy, I want to talk to those guys more. They were so much fun today. So if you would like an introduction, I'd be more than happy to make that for you. Feel free to reach out to our team at info@mobiusconnect.com. Otherwise, I hope to see you at another WOW 11 session. Again, we've got a few more wrapping up today. Otherwise, thank you guys so much for participating, and we will be in touch soon. Have a good rest of your day.